Good morning, everyone. We'll go ahead and get started. So if you all sit down. My name is Sandy Magnus. I'm the Executive Director of the AIAA, and I'd like to welcome you to Day 2 of Space 2013. I hope everyone enjoyed the sessions they attended yesterday. I know I learned a lot listening to some of the comments that we had about how to survive in the environment we're currently in and the benefits of commonality and what the breaking the curve that we need to do in order to do projects a little bit more efficiently and at lower cost. There were a lot of really good ideas floated around yesterday. We had a lot of good questions. So I think it was a great session for everyone, the audience and the panelists, at least the ones that I attended. Today we'll have Day 2. There's a lot of great conversations ahead of us today. I hope you enjoy them as well. We are going to have lunch today with a panel session. We're going to start lunch on time at noon, so please expedite your entrance into the luncheon hall today so we can get that started and make sure we have enough time for the panel to really go into the asteroid mission that we're going to talk about at lunch. And I would like to introduce Jeff, or invite Jeff to come up again this morning. We'll have an award first, and then we'll go into the panel session after that.
Thanks very much, Sandy. I'm Jeff Puschel, the Recognition Chair for Space 2013. I'm also have a day job at Raytheon. I'm very pleased to present another very prestigious AIAA award this morning, the Space Automation and Robotics Award, to recognize an achievement that I think is absolutely amazing. It's a government-industry collaboration between NASA and General Motors. We celebrate the Robonaut 2 development team for their pioneering technical achievement and advancement of humanoid dexterous robotics for human space exploration. Accepting the award for this team is Ron Diffler, Principal Investigator from NASA Johnson Space Flight Center. Please join me in welcoming and congratulating Ron. Congratulations.
Thank you very much. On behalf of the entire NASA General Motors team, I'd like to thank you for this very prestigious award. We've been making some excellent progress with the first humanoid robot in space, and we expect to continue to do so. Thank you very much.
I did look yesterday from down there. Was it? Okay. Okay, thank you. Thank you, Sandy.
I was talking with Ron while we were waiting to get us started this morning, and he was telling me the next set of experiments they're going to do with Robonaut on orbit is they're sending him a pair of legs so he can translate around the space station, either by using grippers on the handrail or interfacing with the seat track. And so I think it's going to be really interesting to pay attention and watch how the Robonaut continues to evolve in its life in space. And I guess eventually we'll see it go outside when the funding and the timing allows. So, Ron, I think you mentioned you were going to do a demo this morning. Okay, at 9:30 there's going to be a demo of the RoboGlove, which is a spin-off of the Robonaut technology. As we're all aware, all of the great technology that we create in the space programs gets spun off for a lot of other applications. So that'll be in the exhibit hall at 9:30 if you're interested. So keep an eye on the Robonaut project. It's doing really great things. Yesterday we had a chance to thank the Executive Steering Committee and the Forum Organizing Committee as they worked very hard to put this conference together, but there's also the technical community that you know of works very hard as well, and I want to just give Technical Program Chair Randy Kendall a very big thank you. He's from the Aerospace Corporation, and he helped get the track chairs and the session chairs and that whole community organized and provided all of the great technical talks that you'll be seeing today and tomorrow and of course yesterday. So let's give a big round of applause to our technical community and Randy for their work. Great job. Okay, this morning we'll get started with this morning's panel session, which is the synopsis is we're going to debate on, while there's a lot of debate on where to go next in space, there's a community of people who are going for inspiration and for profit in a commercial kind of a way, and we're going to talk about that today. And the questions that are before us is we've got to, nationally we're trying to figure out, what the right process is, the moon, the asteroid, the Mars, and we'll hear some more conversations about that. But the private community, the entrepreneurial community is moving ahead. And so how do you create synergies? How do you use the synergies between these different groups who are interested in exploring space, and how can we leverage off of each other? How can we help each other move forward and do that in a very efficient and collaborative way? So you hear some of those conversations this morning. To lead our panel this morning, I'd like to introduce Mr. Bruce Pittman. He's a very appropriate person to lead this conversation, having lots of experience in industry, as a contractor, civil servant, entrepreneur. So he's seen the problem from a lot of different angles. He is currently working as a contractor at NASA and Ames as the Director of Flight Projects and the Chief System Engineer for the NASA Space Portal in the Emerging Space Office. He is also the founder and president of Profit Engineering Technologies. He has been in the business for 30 years, working as a civil servant, as I mentioned, Ames for 11 years on a variety of space projects, and also as a founder and a member of a lot of startup teams and growth companies, including Space Hab, Kistler Aerospace, New Focus, Product Factory, and Prometheus 2 Limited. He's also been a consultant with many Fortune 500s. So as I mentioned, Bruce is a great person to moderate this panel, having seen the industry from a lot of different angles. So Bruce, I will turn it over to you and we can get started. Thank you, Sandy.
Well, it's a pleasure to be here today. So on behalf of not only the AIAA, but the Commercial Space Group, I want to welcome you here today and congratulate you for being able to get up so early in the morning. How many of you knew, let me see a show of hands, how many of you knew that there was a Commercial Space Group in the AIAA? Okay, well, good. Anyway, that's good. Sometimes I wonder. At a number of conferences, I've heard people ask what commercial space is, what isn't it, and so I thought we should put that to rest here. So up on the screen, I tried to follow Gerst's example and with no charts, but this is my one chart. So one chart. On the left there, this is the National Space Policy of the United States of America, June 28th, 2010. And it's only about a 14-page document, and they spend one whole page talking about what commercial space is and what it isn't. So I just wanted to read that to you for the people in the back that can't see it. It says, the term commercial for the purposes of this policy refers to space goods, services, or activities provided by private sector enterprises that bear a reasonable portion of the investment risk and responsibility for the activity, operate in accordance with typical market-based incentives for controlling cost and optimizing returns and investment, and have the legal capacity to offer the goods or services to existing or potential non-governmental customers. So that's what, the administration says that commercial space is, and I think it's a pretty darn good definition. And as Sandy said, I've been in this from both sides. Got to admit that it's getting closer to 40 years now than 30. But that's another story. But I have seen a lot of changes in that period of time since the early days in the mid '80s when we were trying to get, if you'll pardon the pun, Space Hab off the ground. It's a much easier sell right now. I mean, back then people looked at us as if our head was on backwards and we were speaking, Swahili. So it was a much tougher sell back in the mid '80s, and it's a much more receptive environment today. I was intrigued by the topic of this panel, space exploration for inspiration and profit. Now, there's two terms that you don't hear used together in the same sentence very often: inspiration and profit. So, is it possible to do exploration in such a way as to do both of those things? And for the purpose of this morning session, I would like to use profit in the most general term, not just financial term, but as far as gain, so that our NASA representative here can do, because NASA's not there to make a profit, but they are there to help move the country forward and to provide a gain. So I'd like to use that in the most general sense of the word here. To set the stage for this, I wanted to make a few introductory comments that may provide some context for this discussion. Yesterday, one of the speakers mentioned, the famous Chinese saying, may you live in interesting times. And that's often referred to as the Chinese curse. But it's also a blessing, for we truly do live in interesting times. But we also live in chaotic, frustrating, and somewhat scary times as well, because of all the things that we talked about yesterday: the budget uncertainties, the changes in direction that we seem to go through on a fairly regular basis. And so you say, what's going on? Well, my take on this, and I wanted to share with you, is that to me we are in the middle of a rather fundamental paradigm shift. And the chaos and confusion that you see around you, the reason for that is this is what a paradigm shift looks like when you see it from the inside. And you all are getting that experience of seeing this change from the inside. And, frankly, it's not always a lot of fun. But it is, they are necessary and they are unavoidable. So if you've studied the history of paradigm shifts, and it's such a ubiquitous word now that it's greatly overused, but I was fascinated by this when I first came across the concept back in the 80s. So I sat down and I read Thomas Kuhn's book, The Structure of Scientific Revolutions, that he wrote back in the 60s, where he coined this term paradigm shift. And in the context here, paradigms are basically about rules. It's rules and models for success. And it also sets boundaries for what's allowable and what's not allowable. So that seems pretty straight. You can see that would be a very valuable thing to do. But it's also a recipe for solving problems. So can you use the existing paradigm to solve problems and to answer questions? And again, that's a very valuable thing to do. Now, why do we have to change paradigms? Because you get to the point where you start coming across problems and questions that the existing paradigm can't answer, or can't answer very well. And when Kuhn was writing his book back in the 60s, he was basically a scientific historian, and he was looking at the transition from, say, Aristotle to Newton, Newton to Einstein, Einstein to Bohr, with the whole quantum mechanics. And you can see a trend there, that there were fundamental views about science that were very dramatic and abrupt. And so he was trying to understand, why that happened. And one of the reasons that this is that the people that have a vested interest in the existing paradigm are very much threatened when that paradigm starts to change, and they try to hold on and keep things the way they are. So there's this dynamic tension between the past and the future that we're seeing in play right now. And that's what we're trying to do. So one of the things that our group is trying to do, the commercial space group is trying to ease that transition and trying to say there is pieces that both sides can learn from each other. And I'm going to go into that more in a minute. Let me put in a plug for our event tonight. If you want to learn more about some of the new things that are happening and some of these public-private partnerships that we'll be talking about as we go along here, Dan Rasky is one of my colleagues from NASA Ames, and he's going to be giving a talk at 7 o'clock tonight over in room 33A on this thing we call the commercial leverage model, which is trying to take the lessons learned from COTS and applying it to new exploration and other NASA objectives. So he's going to be doing that tonight, and I would encourage you all to attend. I do know that that makes for kind of a long day. So one of the things that happens in this whole process of paradigm shift is things that were working before start working not so well. And strategies that had been, very successful start, not being as successful. And you can see this in the entrepreneurial community whether, we were talking about this last night at the cocktail hour, whether you're talking about IBM's mainframe computers having to give way to the DEX mini computers, to then Apple and IBM's, personal computers, and now this whole concept of the cloud, and saying, do you even need a personal computer at all? Is there a similar analogy for the space industry that we can draw from these other industries? So today we have two entrepreneurs here that are trying to go beyond low Earth orbit and exploit the resources of the solar system, one to the moon and one to an asteroid. And then we have a NASA person, a civil servant, who's trying to develop a system to also go beyond the low Earth orbit, but with people, and actually ultimately send people to Mars. So these are very audacious kind of undertakings. So is this possible? If you kind of go back and do your history, you'll notice that we haven't sent anybody beyond low Earth orbit since 1972. With the end of the Apollo 17 mission, no human being has been more than 400 miles off of the surface of the Earth. And then especially when you want to look at doing this for profit. So for the government, you can say, well, governments have traditionally done this, but can you do this and make a profit? Now that's a truly interesting concept. So we know that with communication satellites, we can do this from a geostationary communication satellites and now remote sensing, and those, as was mentioned yesterday, these are multi-billion-dollar markets for these various technologies, and of which the commercial sector is a very large percentage. But actually going out and mining foreign bodies. So what I wanted to do is to just play a little historical game here. Just to remind us, this is the AIAA, and there's an aeronautics part in that. So I just wanted to give you a little refresher. So December 17th, 1903, two bicycle mechanics from Dayton, Ohio, did what a lot of people said could not be done and demonstrated heavier than air flight. So what happened after that? Did the world come beating a path to their door and they were wildly successful and aviation just took off, if you'll pardon the pun? Didn't happen. Didn't happen. A lot of people didn't believe it. It was outside of their paradigm. They just didn't get it. And the people that did get it said, what do you do with it? This looks like a toy. This looks like a piece of something that you do if you don't really value your life. But they were persistent. In 1908, they got the first government contract with the Army Signal Corps, which was an interesting choice. And the first demonstration flight didn't go so well, and the plane crashed. Orville Wright was severely injured, and the observer, an Army lieutenant, was killed. Say, that didn't start off so well. But they, again, persevered. An interesting thing happened in 1915. There was established an organization called the NACA, the National Advisory Committee for Aeronautics, because by 1915, the United States was hopelessly behind our European allies and adversaries in aviation for a number of reasons. So the NACA was set up to try to correct this. And what you see was a series of things that they did with very little money initially in a very few number of people, but they did some very strategic things that really helped out, including the Kelly Airmail Act that they helped pass, the establishment of the Civil Aeronautics Board, and the Weather Bureau expansion to include aviation. So they did a number of things in a more regulatory and policy kind of area that were very helpful. In 1925, the Ford Trimotor was brought online, and the old Tin Lizzie. And that kind of opened up aviation for a lot more people. And then in 1933, the DC-3, or actually it was the DC-1 back then, was brought. And the reason that plane was developed was because TWA had a crash in the early 30s, and Newt Rockne, who was a very famous football coach back then, was killed. And so they needed a new airplane because the crash had been a Ford Trimotor, and they needed a new airplane. So they developed the DC-1, of which only one was made, which led quickly so that flew in 33. In 34, 35, the DC-2 flew, and they made 198 of those airplanes, flew in 1934. The DC-3 flew in 1936. And it held, they went from the DC-1 and 2 held about 12 to 14 passengers. The DC-3 went all the way up to 21 and eventually up to 32 passengers. And over 10,000 were built, many of them for the military in World War II. So you can see this progression. So from 1903 to 20, 30 years later, aviation was starting to take off. And then a rapid evolution, especially after the war. And in 1958, the Boeing 707 was introduced. So what is that? That's 54 years from the Wright brothers' first flight to the Boeing 707. And then it was 11 years after that, 1969, that the Boeing 747 first flew, and also when humans first landed on the moon. So you can see there was a rather interesting historical progression there. So the question that I asked today is, if you had gone back and asked Orville and Wilbur, what do you think the real potential of this device that you're building? Do you ever think that it will have, that hundreds or thousands or millions of people will be flying across country, or that 6,000 tons per day of perishable goods, vegetables, fruits, and cut flowers will be transported between continents at commercially economical prices? What do you think they would have said? Even they would have thought you were insane. So the point here is that the future does not need to look necessarily like the past, that fundamental and profound changes are possible if we will examine our paradigms and make the appropriate changes to kind of embrace the future. So that's kind of what we're here to talk about now: inspiration, profit, and the exploration of space. And to do that, we have an outstanding panel for you today. So on your right there is Chris Lewicki. Chris Lewicki is the President and Chief Engineer of Planetary Resources. Prior to joining Planetary, I used to like your old title, which was, was it Chief Asteroid Miner? Okay, I kind of like that one. It has a little more zing to it, And prior to that, Chris had a distinguished career at the Jet Propulsion Laboratory just up the road here in Pasadena. He was the flight director for Spirit and Opportunity, as well as participating on the surface mission manager for the Phoenix lander. So he was a Mars guy who's now been wooed by the asteroid community, and so now he's off to new horizons. Next to him is Bob Richards. Bob is a founder. I mean, Bob has founded a lot of stuff. He founded SEDS back in his early days, the Students for the Exploration and Development of Space, and it turns out that's where our paths first crossed, although we didn't know it back then. He's also one of the founders of Singularity University, as well as the International Space University and a number of other organizations. Bob is also one of the founders of two Lunar X Prize teams, Odyssey Moon and Moon Express. He is now the president, CEO, and all-around chief moon miner for Moon Express, and they are planning to go back to the moon. So Chris is the asteroid guy, Bob is the lunatic, the moon guy, and next to them is Dan Dunbacher. Dan is the Deputy Associate, this is a great title, Deputy Associate Administrator for the Human Exploration and Operations Mission Directorate in Washington, D.C. So he works for GERST, and so he's basically responsible for the beyond low Earth orbit exploration development that NASA is undertaking now, so both the SLS and the Orion. So you can see that he must be a very busy man, trying to keep all that stuff on track. Prior to being lured to Washington, D.C., he was the head of the engineering directorate at the Marshall Space Flight Center in Huntsville, Alabama, where he had a staff of 1,400 civil servants and about 1,200 support contractors in his directorate. So a very large group of people. He was also involved in previously in his career in both the X-33, the DC-XA, the X-37, and a variety of other flight missions. So so you can see we have a very an experienced panel who's well positioned to talk about this topic. So without further ado, I'm going to get off the stage and turn it over to Chris.
All right, good morning, everyone. Bob and Dan and I chatted before the session, decided we would give our comments here from the panel. Happy to be here with everyone again at another space conference with AIAA. I've been an AIAA member for a long time. Also, hello to everyone joining on the live stream, watching from elsewhere in the world. To start things out this morning, what we were going to do was spend a few minutes talking about what we've each been respectively working on, kind of our goals and recent progress in that, and then Bruce will then continue to lead us through a discussion on the aspects of space exploration for inspiration and profit. So, starting with planetary resources, for those who are not familiar with the company, I'll just say a few quick things about what we're working on, why we're working on it, and why we believe that we can make progress and maybe even one day achieve a goal as audacious as asteroid mining. And the mission of the vision of the company is actually broader than mining or space. It's really about our species and about humanity, and extending the economic sphere of humanity off the surface of the planet into the solar system. This is something that is both an opportunity in terms of exploring new frontiers, and maybe in some ways an imperative from what we have recently seen with things like the Chelyabinsk meteorite coming in earlier in February of this year. And for me, I think about long-term, what we're working on, and Bruce talking about the story of orbital and Wilbur Wright and kind of looking at the future and envisioning what might happen. The thought of humanity being confined to the surface of the Earth for all eternity is both utterly depressing and somewhat terrifying. So in my background of having spent a good chunk of time working on government-funded efforts for government purposes, both from the perspective of the NASA Jet Propulsion Laboratory on Spirit and Opportunity from one perspective, and then seeing a commercial approach in terms of a government contracted supported effort on the Mars Phoenix lander, and now kind of in a third tour of seeing what Bruce was describing as a commercial effort that we're bearing a substantial portion of the risk in pursuing this stuff. This is something that I think it's important that if you think that something can be done or you think that we can move forward, you have a personal imperative to try and do something about it, either from the seat that you're sitting in or going and finding a new way to do that. So asteroid mining is a very large undertaking, and much like the rest of the resource industry here on Earth that has been working for as long as we've really been a civilized society, mining starts with prospecting and understanding the resources. And there's an element of tools and tool sets and science and knowledge that goes with that. And fortunately, the investment of not only the US government, but the other governments around the world have paved the way for the last 5 decades in creating that capability. We have learned more about space, learned more about the moon, learned more about the near-Earth asteroids in just the last 10 or 20 years than we have in the existence of everyone here. And it's really a great time to kind of be taking these things up and looking at the next step. So our near-term focus is prospecting and looking at these objects in space, not for how they advise the history of the formation of the solar system and what it means about the isotopic ratios of things with respect to each other, but to put it quite bluntly, how we can make a buck on it and how we can build an infrastructure that actually gets humanity off the surface of the planet and into the solar system. So for asteroids, and this really applies to much of everything, there are 3 broad categories of resources that are of interest. The headline-grabbing items are the rare things like the platinum group metals, 6 really extraordinary elements with incredible properties that are actually 1,000 times more scarce in the Earth's crust than the rare earth elements that make the headlines so often. And these elements, of course, are extremely useful for their catalytic properties and their other elemental properties, more so than just because they're valuable because they happen to have a large price on the market. So this is something that we know from the meteorite population that we have 50,000 samples that have been conveniently delivered to our laboratories by the solar system over time, that these materials are certainly out there. And there is an opportunity to turn something that is scarce into something that we can have an abundance of. But before we get there, we're probably going to have to cross through a couple of other places. There are structural materials, things like iron, nickel, and cobalt, things that you build Starship Enterprises out of. You wouldn't build that stuff in Kansas floating above the countryside, probably as shown in the movies, but you would source that material from space, and even though it's not the titanium, aluminum, and other exotic alloys that we're used to working with, iron, nickel, and cobalt will be the stainless steel and the construction material of space, and it is in space, outside the gravity well, in extreme abundance when we're ready and able to make use of it. And what will really open things up in the near term is energy. And energy, in broad terms, is the ability to do work, the ability to essentially command these other resources. And it takes a couple different forms. In the form of water, supporting human life, potable water, growing plant life, we're mostly made of water. But also being able to use it as radiation shielding. And the trouble that we have with going to Mars and thinking about how to develop systems that will protect us from what is believed to be unprotectable in cosmic radiation in terms of defining technology. The Earth's atmosphere and magnetosphere does a great job of this. And a cubic meter of water goes a long way to providing human life that protection. But ultimately, the real interesting part is taking that hydrogen and oxygen and using it as propellant. There may be, from a technology standpoint, much more efficient ways like xenon and ion propulsion to achieve high ISPs. But when you have fuel in abundance, the efficiency becomes less of a consideration. And you now have the ability to do just about anything else you want in the solar system. So our first target is water and providing fuel to fuel depots, whether it's near Earth, on the way to Mars, or other points of space that we want to operate in. And all the aerospace engineers in the room certainly know about the rocket equation and the difference between distance in space and energy potential in space. And most of the world thinks of space in these terms, that we've got International Space Station and most of our human exploration relatively close to home. We've been to faraway places like the moon, and we have been dreaming for a long time of going to Mars. And they all seem very far away, but from an energy standpoint, as Robert Heinlein had said, once you're into low Earth orbit, you're halfway into anywhere in the solar system. And it's this recognition that as we pioneer into space and as we create infrastructure, we are going to create the capability to not have the surface of the Earth as our rally point, but a surface above the Earth. It may be low Earth orbit, it may be a Lagrange point, maybe the surface of the moon, it might be Phobos or Deimos in Mars, but all of those destinations are much closer to each other than the 9 kilometers per second that it takes to even get started on that journey. So that's why really sourcing fuel and sourcing materials from in-space for an in-space market is just a tremendous opportunity. And if we are going to do this sustainably and indefinitely, we need to move beyond sending in supply ships over and over. So our development strategy at Planetary Resources, I'll let you read most of these bullets. The real crux of things is that space exploration has cost so much money in part because it has cost so much money. We spend a lot of money on it. We want to make sure that it works, so we spend more money to make sure that it works. That takes a lot of people, a lot of paychecks, huge infrastructures, and to simplify things, the process of prospecting to learn about resources is actually relatively simple. This is technology that probably was pioneered in the Mariner missions in the 60s. And we have technology that's capable of doing much better than the Mariner missions. And as Burt Rutan had shown in human exploration with Spaceship One and scaled components, small teams of people are now able to do what large industries and governments were once able to do. So being able to do like SpaceX is doing and bring much of the work in-house, vertically integrating to solve your own problems in risk-tolerant ways, turning things into information technologies, leveraging Moore's Law, leveraging autonomy, and really taking advantage of the rest of the world's innovation. Aerospace and space exploration was once the font of all sorts of innovation when we first started doing it, but other industries have long since passed many areas of space in terms of innovation, and we're looking to bring a lot of that back into aerospace. And then last, of course, is recognizing that this is not a space endeavor, it is a resource endeavor. We're part of an industry that has existed for a long time with mining and resources and energy, and we're really just creating an extension of that industry. Aerospace is our tool for doing so. But we're part of a very productive and a very long-range thinking, multi-decade timeline exploration strategy of these things. And there's opportunity to essentially make money and create value at every part of the value chain. So moving along, we're working on prospecting technology, essentially robotic space exploration missions where we can field an asteroid rendezvous and characterization and valuation mission for starting at, we're aiming for about a 20th the cost of missions on the books right now, something on the order of, let's say, $50 million instead of $1 billion. And this is something that we think after a few iterations we can actually get to 100th of the cost. To be able to take risk in a different way. The prototype of our Deep Space Explorer is our Arkyd series of spacecraft, the Arkyd 100, which will be launching in 2 years in Earth orbit as a technology demonstrator. This is something that, I'll talk in a little bit, we recently opened up to the public. But this is essentially what we want to put at the tip of the sphere for getting out to the asteroids, taking advantage of all of the mass that we can and the opportunity for secondary launches to do very low-cost asteroid prospecting, because we're going to need to go to many more than a single target to really find the best resources in the solar system. With the Arkyd 100, not only will we be developing technology, but we'll be doing essentially some niche roles in terms of asteroid characterization, finding those moving objects, characterizing the Earth-crossing asteroids, determining spin rates, doing light spectral work, and essentially being able to identify the resource interest in these asteroids more so than just whether they're a potential hazard or the broader scientific interest, where we're looking for water, and our Arkyd 100 will start doing that. So from orbits to spectra to light curves, we've got a catalog now that is now over 10,000 near-Earth asteroids, and we've really just begun. We've found most of the hazardous ones, but there is so many more resources that are available, and from a getting starting standpoint, there's an aspect of these that's attractive because of their location in space and the gravity well, and that in many cases they are not too much farther than inserting a spacecraft into geostationary orbit or even landing on the moon. In some cases there's less energy than doing that. So more on the inspiration line of things, in June we ran a very successful crowdfunding campaign on the platform Kickstarter. And this was a complete experiment for us, one that we were ready to face total failure, but we wanted to answer a basic question. And the question was, does the general public care enough about engagement and outreach and access to space to the extent that they'll help fund it? We have no commercial interest in outreach. It sounds a little bit harsh to say it that way, but we have shareholders, we have a business objective, and we need to pursue that objective efficiently. And unlike NASA, for example, we don't have a charter for public engagement. And we put out a couple different ideas for public engagement to test them out and see if there was sufficient interest, and nearly 18,000 people demonstrated that there certainly was. So this is something that really shows that people continue to be inspired by space, continue to be interested in it, and really want to help make this happen. As a part of that, we unveiled a citizen science activity in partnership with the Zooniverse. We're creating an asteroid zoo, and this is a beginning of a technology effort that we also have submitted into NASA in the Asteroid Initiative RFI process, and we'll be talking more later about this month at that workshop, of the ability to essentially use citizen sciences and community activities to take some of the most difficult problems, autonomously categorizing moving objects in astronomical surveys, and being able to tell the asteroid from the noise. And ultimately, I'd like to take this process and automate it to the extent that we can, instead of running it on a supercomputing Linux cluster, we can run it on an embedded system in the spacecraft, whether it's an Arcid Space Telescope, a Sentinel Space Telescope, or NeoCam. All of these different missions can benefit from the ability to harness the power of the crowd to really solve the most difficult challenges. We've also announced in June that we are partnering with and have gotten a major investment from 3D Systems Corporation, the very large additive manufacturing company. And this is one of those technologies that truly is invented for space. To be able to create material in an additive way using feedstock that is derived from space is the ultimate in space colonization and establishment and creation of infrastructure. So we're working with 3D Systems to take some of the most advanced manufacturing techniques that are available today and learn how we can apply them to aerospace and spacecraft design to help bring this cost down, and not only for reducing the cost, but to enable things that just aren't possible using conventional manufacturing techniques. And then later next year, we're under contract with NanoRacks through their Space Act Agreement with NASA to do an early technology demonstrator of some of the core vertically integrated technology that we're developing for the Arcid 100. Reaction wheels, embedded computing systems, star trackers. As a result of our Kickstarter, we have our selfie camera that we'll be testing out on this mission. And these are things that essentially we've taken the avionics package out of our deep space spacecraft, and we are looking for every opportunity to test it in an appropriate environment. So CubeSats and even high altitude work, there are so many ways to test things and simulate things with technology today that we just really want to take advantage of every one of them. So that's really the end of my comments this morning. From a commercial standpoint, and Bob and I have talked about this a lot, I'm sure he'll comment on this. We really see an opportunity for building on the groundwork that has been laid by our national space programs, really pursuing things that a government program wouldn't have the motivation to do, and finding those things where there are opportunities for us to leverage each other's best interests and capabilities. Keeping in mind, of course, that we do need to take market risk. We do actually need to have something that is outside of the monopsony of government contractors working for government agencies. And success isn't assured, and we might fail, and the risk might be too great. But it's a path that, by being able to take this private commercial risk, some innovations will certainly come out of this, and what the future holds is kind of uncertain, but it's very exciting to be to finding this out and finding out what it is that the market and the universe will bear. Thank you very much.
So thanks, Chris. You've learned well, young Skywalker. It's with great pleasure that I've been invited to address you this morning as well. I very much do like the title of the panel. I think in my case it might have been because of inspiration for profit. It was the early day. I mean, I'm an orphan of Apollo. It was that inspiration that really set me on a course which was irresistible in my attraction to trying to do something and be a part of this amazing space movement that we've had for the past 30 years. In the first few decades, though, it was really about creating the institutions and the businesses that creates the infrastructure of the human capital, this inspiration, the vision, the people that can actually fulfill that kind of false dawn that we, in our under 10 years, witnessed with Apollo, and create that amazing future that we thought we were promised, to go to the moon and Mars and have the Enterprise flying through galaxies, visiting planets every week. So it was the moon that became my destination of choice. And I think what you'll find as I give you a little bit of a brief, that there's a lot of commonality in what Chris has talked about. As far as the business strategy, it is about resources. In the business tactic of Moon Express, rather than going to the source in free space, it's our business thesis that going to a gravity well that has been collecting asteroid resources will be profitable, and we'll see. I mean, there are more variables than there are answers in any of these business plans, and that's where the entrepreneurship comes in. Just to give you a little bit of an overview in a promotional way, I want to show you a brief video, just 2 minutes, that shows you the type of overview that Moon Express is involved in as far as our business aspects. So if we could roll that video, please, and then I'll come back to the slides.
Space is going to be the next big industry.
I suppose your company is getting me closer to the day when I might find myself on the moon.
Moon is nothing but another continent from our perspective, and just like any other continent, we want to use that continent and the resources from there to make life better for all of us here.
Bob Richards, CEO of a California startup called Moon Express, believes that the first trillionaires will come from space.
I see the moon and the moon sees me, and soon I can see from the moon.
We can now travel to other planets and bring resources back from there.
Leading the world to space helped America achieve new heights of prosperity here on Earth.
Using the ingenuity and cost effectiveness of private enterprise, we're going back.
The team have been designing unique landing gear and cutting-edge miniature radar systems.
There's nothing new about getting to the moon. It's about doing it, applying innovation and disruptive technologies so small teams can do what only superpowers could do before. We will be sending robotic landers initially to the surface of the moon, carrying scientific and commercial payloads. Then we'll get into the era of exploring for resources and learning how to process those resources and bringing them back to Earth.
The moon, unlike Earth, has not been molten for 4 billion years. Okay, so the things that hit have stayed on the surface, and it doesn't have an atmosphere to burn things up. I think there's more platinum on the moon than there is in all the mining reserves of planet Earth.
The platinum, the rare earth elements, plus you have helium-3 that essentially you can use for fusion energy. In a small amount of helium-3 could provide energy for the whole planet for hundreds of years. So it is not just a fun project, it is also a great business.
I just see it as a beginning, an instant in history.
We are those crazy people who think that every idea is a crazy idea until we make it happen, and then people say, of course.
Thank you. So is there a lot of enthusiasm and excitement? Absolutely, about entrepreneurship in space. And if I could just go through a few slides here. The moon what did I do? I did something wrong. There we go. Yeah. All right. So the moon is a child of Earth. We talked about how the resources delivered by asteroid and comet bombardment over the eons has enriched the moon very much like it's enriched the Earth. So the thesis of the company in the long term is the development of lunar resources for economic benefit of humanity, both on Earth and in space. As Chris had mentioned, developing the economic sphere of Earth outward from our low Earth orbit and geosynchronous satellites that we currently have. Now, it's a moon rush in our view, as we look at it. The moon has an enormous attraction psychologically and emotionally to the human race. It's very convenient that it's a sister world, which is just on the horizon, part of our planetary archipelago and drawing us. But the question is, what's the on-ramp for a business towards that large vision of exploiting lunar resources, which is arguably billions of dollars of infrastructure before you could economically mine resources of the moon. So our on-ramp as a business is actually to provide payload services to the lunar surface access. So lowering the cost of access to the surface of the moon, not unlike SpaceX and others are lowering the cost of access to space, will open up new markets. And we want to lower the cost of access to space by an order of magnitude or more that allows citizen science and students and universities and that level of access to the moon to do research. At the same time, moving forward with our own company interest of prospecting and learning how to operate on the moon and learning what's there. Our first mission is scheduled right now for 2015. We're calling it our tech demo mission. None of us in the commercial sector are saying this is easy. Of course this is hard. We're taking on enormous challenges with small groups. From a large-scale company's perspective, our groups are like skunkworks groups. We have about 30 engineers working really, really hard on a massive challenge. So our first goal as a company is just to land on the moon. Just do that. And that would be a great success for us. If we can actually prove some of our operations, serve some of our customers like Google who wants to see some video and some pictures brought back, serve some of our other customers that want to send payloads to the moon during a 2-week first mission, that is even better. We're also looking to our second mission, which we announced quite recently, which is in partnership with the private sector customer, the International Lunar Observatory Association. Steve Durst is an American educator, entrepreneur, philanthropist who has a dream of putting a telescope in the south pole of the moon to expand the experience that is given to students and the general public of being able to see new perspectives in the cosmos. It's not going to rewrite the astronomy books. It's not going to be the Hubble Space Telescope. It's going to be the Hubble Space Telescope. But it's going to be accessible to people over the internet. People will be able to control this telescope on the moon. And so that's, while we are sending that system, and please don't take literally at all this artistic rendering of the tuba on the south pole of the moon, we will be unveiling the actual engineering of this craft very soon. Our third mission, this is the holy grail for the company, which we expect to be able to execute sometime in the 2018 to 2020 timeframe, is actually a sample return mission. Everything that we're doing as a company is building up this capability of being able to bring resources back. We think that is a profitable thing to do. We think it'll be a very inspirational thing to do. But also it'll be setting the legal precedents, the case law that we need for the larger operations that we'll need in the future. We're going to start small, baby steps, and go from there. If we could bring a kilogram back of moon stuff that we own and we can sell, that would be great. And that's what our investors are very excited about. NASA is our partner and our customer. It's a very important relationship that we have. It's a partner in that we have a reimbursable Space Act agreement in place, actually with 2 centers to date, both NASA Ames and with Marshall Space Flight Center, that allows us to pay NASA for select technology and expertise and help for us to learn how to do these very hard things. So that's a very, very important mechanism that we've been able to take advantage of. NASA is also our customer in that we have a contract called the Innovative Lunar Demonstrations Data Contract, ILDD, which is in some sense like a lunar COTS, an extension of the COTS model, where NASA pays us, doesn't fund us, but pays us for data generated by predetermined milestones with a predetermined value that's only payable on success. So it's a great model where the risk remains with the company and with the investors, but based on our growth and our capability and our accomplishments, NASA could buy the data from us as we reach the moon. And so it's a great value proposition for both organizations. We're also building stuff. We announced a couple of months ago that we've opened up a propulsion development facility in Huntsville, Alabama. For those of you who recognize Tim Pickens there, who joined us as our chief propulsion engineer, you'll know that this means we've embraced his man cave out in Huntsville and all that fabulous stuff that he has out there. And if you know Tim, he's a tinkerer and he's a junkyard dog and he does amazing things. As the chief propulsion engineer on Spaceship One, he created innovation for Burt Rutan. As our chief engineer, he's creating innovation again. And we're developing, as Chris had mentioned, part of our philosophy is to bring everything in-house that we can. We're highly vertically integrated. And I didn't expect that Moon Express would be a rocket engine development company when we first founded it, but that's where we are. And we're developing 3 new systems. They are hydrogen peroxide and kerosene-based propulsion. It's something that has not been embraced widely at all in the Western world. It has been embraced by the Soviet Union in the early days, and there has been some military flights. And if you are familiar with the Mighty Eagle, which is the platform that Marshall has created, that is a hydrogen peroxide system as well. So metaphorically, we're building a railway to the moon. The first engines going there will be steam engines, right? Because it's hypersonic steam that comes out of these engines. So I like that very much. Why? Because water is the fuel that's there on the moon. So we're building our propulsion systems to be compatible with the fuel that's waiting on the moon that makes the economics possible of the lunar resource development. So we've gone through a series of tests with our early engines so far. These will be developed into larger systems in the coming months, and we're also flying stuff. We're right now, actually, and we'll be announcing this with NASA officially next week, but we've entered into a partnership with Marshall Space Flight Center. We have a campaign going on with them right now where we're flying the Mighty Eagle, our software, our GNC. We're flying stuff. Well, we're flying other people's stuff with our software, and we haven't broken it yet, and we hope we won't. But our core GNC is being tested on the Mighty Eagle. It's a very advantageous platform for us while we build our own platform, our own spacecraft emulator and hover test vehicle, which will be flying in about 6 months if all goes well. And another way of partnering with NASA, we cut our teeth on the hover test vehicle, which was developed at NASA Ames, which is now embedded in the LADEE system going to the moon. We're now working with Marshall on flight tests in the air using our own GNCs. So in this progressive partnership with NASA, kind of our training wheels, we'll be taking those off in about 6 months, putting our software on our own hardware and flying that as well to show that we can actually do it ourselves. So baby steps. We have a team of about 30 engineers working real hard up at NASA Ames. Our goal is we're going to the moon, and it's going to be inspirational, and it's going to be profitable. Thank you very much.
Well, good morning, everyone. Again, it's like Chris and Bob, it's a pleasure to be here to talk about what we're doing in exploration. And yes, profit is a little bit different from a NASA perspective, but I think we'll show you what we're doing, why we're doing it, and the capabilities we're putting in place. So we do this, as you've heard from Bruce, Chris, and Bob. We're doing this for several reasons. We've focused on the profit potential that can be out there, but there are also other reasons that we're exploring that provide the foundation for achieving the profit. That is, obtaining the knowledge, learning what's out there, learning what we need to do and how we need to do it, and mitigating the risk. We do that so that we can provide potential economic growth. That's the profit potential part of this. And then that profit potential and how the space economy, as I refer to it, grows and builds in the future, then leads to the better life that we are all looking for. It improves our ability here on Earth. It gives us eventually the capability to go to other worlds and to learn and to live in a better way. So how do we do that? Well, there are lots of places to go. Our horizon destination at this point is Mars. Now, Chris has hit on the point already, and I will remind everyone that Mars is 100,000 times farther away than the space station. From an energy standpoint, Chris is right. There are lots of other things we need to learn when we do this exploration. We need to learn how the humans will react to and live in the radiation environment for the long exposure, the long trips, the long exposure in space. We need to learn how to operate from a guidance, nav, and control standpoint with the fine accuracies that we need in the different orbits. And we also need to learn how to interact with other bodies in space, such as what we're working on with the asteroid mission. In order to do all of that, this is not just NASA doing it the way NASA has always done it, coming off of the Apollo legacy. We have space station assembled. It's on orbit, man-tended for coming on 13 years. And we are now in the process, rightfully so, of turning over the cargo resupply and crew rotation activities in low Earth orbit to private enterprise and our commercial partners. That's the purpose behind the COTS contracts and the other work that SpaceX, Orbital Sciences, Blue Origins, others are all working on in order to get that private enterprise capability for cargo resupply, similar to the model that, as Bruce was going through the history, similar to the model where the Army the Army at the time helped bring along with their contracts the aircraft industry. Along with that, we're putting the capabilities in place, the long-term transportation capabilities with the Space Launch System, our capability to get crew out to space and bring them home safely with Orion. Those are what I call our foundational capabilities, but we're also working our other capabilities that are needed for this long-term exploration. We're working things like 3D printers in space. We will be putting one of those on space station to learn how that works in the zero gravity environment. We are working with B612 Institute in order to look and try to find and track asteroids. We have put in commercial opportunities for environmental control and life support systems and are testing those out on International Space Station. All with the intent of working in the new paradigm so that we can bring along the capabilities, learn what we need to learn to further exploration and to help build the potential for the future, using our capabilities and building upon it. Orion right now is in work at the Kennedy Space Center getting prepared for its first flight test. It will be the vehicle that we have for humans to get to space, get home from space safely. It has a 21-day capability life support system. It also has the capability to stay in the space environment for over 6 months so that it can operate in a quiescent mode and be prepared to bring the crew home and return them safely to the Earth. And you see there lots of our activities that are ongoing, but I'll hit a video here in a few minutes that'll show you some of the other progress. The Space Launch System, also in work, just completed its preliminary design review, moving into detailed design. Production articles being produced at the Michoud Assembly Facility, all getting prepared to build the hardware to get the Space Launch System and Orion to fly in 2017. Ground Systems is proceeding at Kennedy Space Center. Pad 39B is being prepared. You'll see in the video some work on the flame deflectors, We have the lightning protection up. We've redone a lot of the infrastructure, brought it up to modern standards so that we can have Pad 39B for our use, but also make it capable of being used for other users as needed. We are also designing the vertical assembly building and the work platform so that we can use the same high bay for multiple launch vehicles. All in the notion of being able to get the capability in place so that in the long run we meet we can execute the NASA mission needs and then continue on and help encourage the private enterprise activities. This is an effort that's utilizing the capabilities across this country. It's not just a government operation. What you see here are just a few of the suppliers around the country that are working on the Orion Space Launch System and ground systems activities. So very important from the standpoint that we utilize all of the capability across the country. We're also taking advantage of international partnerships with the European Service Module that we will have on our first flight of Orion and work with ESA and Astrium. That is a key activity to be able to have the service module we need to execute the mission. Whoops, I lost my video. There we go. What you will see here in this 3-minute quick video is the progress that we are making across the team and across the country, getting ready for our first flight of SLS and Orion. And all of that effort particularly on Orion, is aimed at our first flight test next September. We just set the launch window for the launch vehicle contract, and we're set up to fly EFT-1 between September 18th and October 18th of next year. The flight article you saw with Orion is being prepared and is on schedule to meet that flight date. In that flight test, we will get 84% of our lunar reentry velocity so that we can test out the key element of the heat shield, along with other key risk areas in the program for all the separation events, the parachute recovery, etc., that we need eventually to fly crew. We are working to mitigate all of that risk, and EFT-1 gives us our first round of flight data to support and inform the Orion detailed design process that will lead to our first exploration mission, currently scheduled for December of 17, where we will go out to the lunar vicinity, execute distant retrograde orbits, similar to what we have planned now for the asteroid retrieval mission that you'll hear about at lunchtime. We are building the systems and the capability and starting to test out the systems and to learn how to work beyond low Earth orbit, and that's what EFT-1 and EM-1 are our first steps in that direction. Leading to the asteroid redirect mission, or asteroid retrieval mission, pick your favorite word, eventually where we will take crew and interact with the asteroid, retrieve the asteroid, and then send crew up with Orion to interact with the asteroid and to bring samples home. So we are working diligently on this. You can see our progress. We are checking off the work that needs to be accomplished to meet our first flight test. The Orion team is doing fantastic on making it all work and making sure we meet the schedule. And we're ready to go, and you will see us flying in 2014. On our way to 2017. Thank you.
So as you can see, some truly audacious and exciting and dare we say inspirational challenges before us here. I think it's amazing. So I'm going to take the moderator's prerogative of asking a few questions, and then we've gotten a few good questions from the audience here. So first of all, let me just kind of do a generic one, and that, whenever you try to do something, audacious, there's always challenges. So I was wondering if you could each of you could kind of discuss what are the kind of the most significant challenges you see before you, and what's your strategy for dealing with it? Anybody want to take that?
Okay, well, I'll give that a go first. I mean, the moon is a very high mountain to climb, and we're just, looking up from the very beginning. It's the sense of entrepreneurship that gives you the confidence in your team's ability to meet the challenges and the unknown unknowns that so entrepreneurship is a thin wall between founder and flounder. You have to know you don't have to know what every challenge is going to be, but you have to have the right team in place and the right practicality of mind and common sense of how to deal with those risks. Our challenge from the very beginning has not really been technical. Not saying that doing the moon is not hard. It is very, very hard, but there's no technologies we're inventing per se. We're not an R&D shop. We're implementing and integrating relatively known and low-risk systems in our initial exploration missions. The highest risk, like most startups and entrepreneurial companies, is the funding. Every good commercial space company needs a billionaire backing it, and we're fortunate enough in our companies to have several of those type of people. But that doesn't mean that they are easy to part with their money, and they're not holding us to high metrics of building our company value and making sure that we are building sustainable and profitable enterprises, which are not stunts and are not play toys. So we've been very fortunate in Moon Express to have great backing from our investors. All the money is not in the bank. It never was. It was never intended to be. But it will be, provided that the company continues to perform on its technical milestones and climb that mountain. Our investors will stay with us. But that's the biggest challenge that we have, is to continue succeeding as a team and keeping the enthusiasm alive of our investors and our partners and those that share the vision with us.
And I'll jump in, I think, because you'll hear a similar answer in one key respect. We are not utilizing or developing any new key technology or making any technological leaps like were attempted with things like X-33 and VentureStar and some of those other attempts in the past. We are working very hard to keep the cost down and to find the ways to do this in the most cost-efficient manner and maintain our ability to safely execute the mission. So that puts us in a new paradigm for NASA, and that is working from the perspective, and you heard a little bit of this in the afternoon panel session yesterday, about we used to treat things as cost as a dependent variable. It just was the fallout after we worked for performance and meeting the mission. And then it was going to cost what it's going to cost. Well, we now are working with cost as an independent variable. Cost is a consideration in every move we make, every design decision we make, and we work hard to minimize the cost within and still be able to perform the mission in a safe manner. That said, our biggest challenge is also the funding. Our funding does not come from private investors. It comes from 536 investors that all have a vote. And we work very hard with those investors so that we can understand where they're headed. And in today's national budget environment, we recognize that there will be limitations and constraints, and we are working very hard to live within those constraints, and the teams across Orion, Space Launch System, and Ground Systems are doing a tremendous job of that, and finding new ways to go about making sure the mission can be executed within the cost constraints.
And I guess my perspective on the biggest challenges ahead are kind of similar things. I think at the top level, it's operating as efficiently as possible towards a productive goal, and one that moves us as efficiently as possible towards our long-term goals. We're working a program that is all the way out to space resource development, and as part of that program, we have a number of missions and technology development and R&D activities, and identifying roadmaps and pursuing those, and really, from an entrepreneurial standpoint, coming up with minimum viable product and minimum viable team so that you can make sure that you are operating as efficiently as possible is both what I would say is one of the biggest challenges and is one of the most fun things to do, because we really have a blank slate in terms of structuring an organization and creating that program and pursuing it with a lot of freedom to really have those constraints drive innovation, not only in technology, but in business practices and other things as we move forward.
Good, thank you. For Bob and for Chris, there's been a number of questions that kind of have a similar kind of a theme here, and a lot of it has to do with kind of like the economics of bringing back resources, like how much would it cost to put in place the equipment to do this? What's it going to cost? Is it really feasible in any kind of reasonable time frame to expect that you can do this in a way that you can make a profit? So, you guys want to take a whack at that?
Sure, I'll go first. In the last few years, I've kind of had the pleasure of bridging a couple different industries and learning more about the mining, mineral, and resource communities. And the surprising thing that I've come to learn is the mentality not of an aerospace program that might have a 3 to 7 to 10 year time frame. In a lot of cases, a mine program is 30 years from identifying the resource to choosing that resource is worthy of the investment, to building a mine, to actually getting to the point where you're turning a profit on it. And this isn't an outside thing, it's actually kind of the routine. And there is a process by which people who make investments in the beginning stages of that mining process don't actually stay the entire number of decades all the way out to the end for their part of the value chain. So it's often a surprise that, at least in the mining community, you can talk about making money and profit and creating value before you ever return any atom to anywhere else. And this is what Bob was talking about, of starting with information activities, science activities, being able to identify where the resource is, and those are things that are of value to a lot of people. So and this all starts too, is that it's not one day that we invent the magic mining machine, asteroid mining or moon mining machine, and roll it up to the ore body and turn it on. It's a process of an R&D that follows R&D that has happened here on Earth mines. You have test mines. The asteroid redirect mission actually represents an opportunity for that type of activity, and extracting water and delivering hydrogen and oxygen to a fuel depot starts with the first test tube of extracted material from a non-terrestrial source. And those types of things are much sooner in the timeline than scaling things up as to the picture that you would imagine that sci-fi authors have painted.
Absolutely. Well, and just to maybe further to that, everything absolutely is relevant that Chris has said. That, these are big picture things, right? We're opening up new worlds. And the questions of ROI and is it worthwhile, and imagine if you're in Europe in the 1600s trying to imagine if the investment would be worthwhile in opening up the Americas, and how would you do that? And well, it's the early stages of that huge idea of exploring other worlds and bringing resources into the economic sphere of Earth. We have, as Chris has mentioned, an industry that the space industry is not yet integrated with. And the mining industry is a completely new mentality and approach to capital for long-term projects. If we're successful, and we seem to be, they don't laugh at us anymore. 5 years ago, if you gave a presentation in front of a mining community and said you're going to mine an asteroid, you'd get giggles. You'd have the giggle factor. Now we have the Google factor. There's at least one big company that thinks going to the moon is really, really important. And Chris and I have both been at several conferences just recently in a few months, and you gave a great keynote at a mining conference in Canada. They weren't laughing. There are thoughtful considerations of how would this work. I threw out a number in my brief talk of billions of dollars of infrastructure that would be required for an economically feasible return of value from the surface of the moon. That sounds like a lot of money. Well, it is a lot of money, but it's not in the realm of the mining industry. Those are typical numbers. An offshore oil rig, $5 billion or so. And so these are numbers that are within the realm. So the existence of water in free space and on the moon is like the oil of the solar system. It is the economic game changer that makes this all worthwhile. So like Planetary Resources, Moon Express is focused on the water right now and learning how to deal with that. And once we have that in place, in the baby steps, those further investments will be attractive.
Okay, and I think we have time for one more question. Yeah, okay. So the final question I wanted to talk about was, if there was one word that was kind of dominated yesterday's discussions, I would say it was the word collaboration. So this whole thing about how do we work together better. So could you guys talk about what are you doing in the area of collaboration, whether it's industry to industry, industry to academia, industry to government, kind of a collaboration. How are you looking to leverage not only your capabilities, but the capabilities of other folks in your ecosystem to help you accomplish what you want to accomplish?
Do you want to start, Dale? Yeah.
I'll be happy to start that one. I think we're looking for just about any tool we can find that works. We have tried many models in the past, and we have learned from those models, and what you see with the arrangements that we have with the commercial crew and commercial cargo activities, the way we've used Space Act agreements on those, the way we're using Space Act agreements and other tools to bring in the next round of capabilities that we need for human exploration, along with the typical contracting modes that we use to develop the hardware, the government-owned hardware. We're looking for all those tools, and the collaboration that you see is working with private enterprise, working with across the board in academia to pull in that capability. And I think our experience on things like the ECLA system we've put up on Space Station, the work we are doing with Bigelow on the his space habitat, those kind of models we continue to build upon. We've learned a lot from things like again, the commercial cargo and commercial crew activities, and we will continue to look for those kind of models to help bring about the capabilities in the most efficient manner.
So my experience, maybe I'll give you the last word since you had the first word, Chris. So my experience has been with working with NASA has been just tremendous. The concept of public-private partnerships and embracing commercial is not universally accepted, but in every center I found the pockets of the people that really move things forward. I mentioned that we have a partnership with NASA Ames and one with Marshall. We're both at Johnson Space Center just last week. I'm heading from this talk to Huntsville and then later this week to Kennedy Space Center. So I'm very engaged with NASA as both a partner and a customer. And to me, it's something that is both necessary and mutually rewarding to do. Chris mentioned that it's not in a charter usually of a commercial company for public outreach and education, and which leads to a lot of the inspiration we're talking about. But that's in my heart, that's in my soul to do, and we continue to inspire and reach out to young engineers who are graduating these days, deciding whether they're going to be asteroid miners or build spaceships or rockets or moon landers. And oh my gosh, what an amazing time we're in this paradigm shift. We're living it from the inside out, and it may not be so apparent, but from the outside world, and the reality is this is just an amazing time, and this transformation that's taking place is not doing so in a linear way. It's doing so in an exponential way. There are technologies and things happening to this world, and that will be available to us in our lifetimes, that will make that grand vision that we all had as kids, as orphans of Apollo, reality. And I'm just thrilled to be a small part of that.
Yeah, I'm excited just thinking about it. It really is, I mean, thinking about the way the world is today, the things that we're undertaking, the tasks that we're pursuing are just tremendously exciting to be involved in. And the timelines in the near term, things always happen shorter than we would prefer. Things always take longer than we would prefer them to in the near term, and in the long term, we accomplish much more than we would anticipate. From a collaboration standpoint between government activities and business to business, and now even both of those elements out to individuals in the community, we're seeing a sea change of the way that technical, scientific, and engineering work can be done with little bits of cognitive surplus around the world of people contributing an hour of their time a week because they happen to be one of the best people on the planet on a certain subject. The ability to get that time to help solve your greatest challenges is a way that the development of technology is letting us kind of take advantage of and give people the opportunity to kind of be part-time rocket scientists, as an example. With regards to NASA's vision and exploration goals and how those can overlap with capabilities in the private sector, there's been a lot of, I think, foundational work done in programs like COTS. The ILDD is a great example. And it's really kind of maintaining the focus of government activities, doing things that only the government could possibly do, building the SLSs and the Orions and sending humans to far-off destinations. But in doing that, there are a number of things that the government, I think, has a lot of opportunity without even really taking much risk, but putting that risk, as Bruce said in the beginning comments, of creating an opportunity that represents a reasonable market risk and something where you actually do have to have skin in the game, and you are only paid unless you succeed. So those are types of things that a lot of the RFIs that have come out over the summer have been exploring these topics. And I think in any of these enterprises, as investments are made in building out infrastructure, there are opportunities to test out ideas and let the commercial sector kind of take those risks to see which ideas are winners and which ideas are losers. And you kind of let the market bear that out. And that really is what commercial activity is all about. It's about taking that risk and being willing to lose, but hoping for the win and investing yourself in it so that you can see that. So I think that's kind of where collaboration is right now and where it's going, and it's thinking about the future economy in space and the future of space exploration, and even just in industry. There's probably 3 or 4 more industries that we don't yet know that our children will have jobs in.
The solar system is big enough for all of us.
Yes, yes.
So anyway, thank you. Please help me thank the panel. So, and if you are interested in to learn more about the COTS model and some of those things, Dan Rasky is going to be talking tonight at 7 and 33A, and the coffee break is going to be next door in the exhibit hall. So if everybody's looking for coffee, which I imagine they desperately are right now, it's going to be next door in the exhibit hall. So Sandy, we're good to go? So anyway, thank you very much, and look forward to conversing with you.